It's funny. Whenever a new flagship smartphone drops, we inevitably end up just obsessing over the camera module, right?
Absolutely. We scrutinize the megapixel count, the optical zoom, the low light sensors.
Exactly. We treat it as this, like, pinnacle of human engineering, a
Yep.
perfectly rational little machine where every single component was placed with absolute mathematical intention by a team of engineers.
Right. It is the ultimate closed system of logic. I mean, we know exactly who designed it, the exact supply chain that manufactured it, and its precise functional limitations. It just feels incredibly comprehensible to us.
But then you take a look at the cameras sitting right inside our own skulls, our eyes, and suddenly that neat, comprehensible engineering logic just gets thrown completely out the window.
It really does.
We are looking at a biological organ that is so bizarrely complex, so hyper-specific in its functionality, that looking at its blueprint raises massive existential questions about how it got there. So, welcome to the Deep Dive. Today, we're taking you on a journey into a very specific, fiercely debated argument about the origins of human biology.
Right. Today we are unpacking a stack of notes derived from a text by an author named Zhu Feng. The work is titled There is a Supernatural Soul in the Universe, and we are focusing closely on chapter 23, which carries the rather poetic title, The Bright Eyes, Windows to Beauty.
A great title, honestly.
It is. Now, the overarching argument of this text is that the sheer statistical improbability of the universe's biology, and specifically the human eye, is undeniable proof of an intelligent greatest creator rather than the result of gradual random mutation. And just to be clear right off the top, to set some ground rules for you listening, our goal today isn't to debate theology or to endorse the text's supernatural claims.
Right, we aren't taking a side here.
Exactly. Our mission is strictly to explore the fascinating biological mechanics, the bizarre thought experiments, and the philosophical logic the author uses to build this case so you can fully understand the source material.
And you're really going to want to hear the lengths this text goes to make that case. I mean, we're going to look at the exact chemical warfare happening on the surface of your cornea.
The military defense systems built into your eyelashes.
Yeah, and even a deeply analytical thought experiment about the biomechanics of humans having eyes on our buttocks.
It really is a wild ride from the microscopic to the macro-philosophical.
It is. So let's start with how we actually interface with reality, because before we get into the why, we have to look at the how. The author points out that of all our perceptive tools, vision, hearing, smell, taste, touch vision, accounts for more than 80% of our understanding of the material world.
80%. That is a massive portion of our reality.
Right. 80% of your reality is dictated by this one single organ. Which means if we want to understand the author's argument for why we're built this way, we have to start by looking at the exact mechanics of how sight actually happens.
And when you break down that bioelectrical process, while it does sound remarkably like science fiction.
Oh, totally.
We experience sight as an instantaneous given, but it is actually a sequential chain of physical collisions. So light photons reflect off an object in your environment. Those photons pass through your pupil and your lens, and they strike the retina at the back of the eye.
Just literally slamming into the back of your eyeball.
Exactly. And from there, those light particles physically interact with photosensitive cells, triggering a chemical cascade that converts light energy into a bioelectrical signal.
Wow.
Yeah, and that electrical pulse then has to race down the optic nerves to the visual cortex in your brain, which then has to instantaneously calculate the size, shape, distance, and color to form the mental concept of what you are actually looking at.
Okay, let's unpack this, because that process is exactly what I want to zero in on. The text highlights a really profound philosophical implication here. This entire process, from the photon striking the retina to the brain fully rendering the image, it takes time.
It does. A tiny amount of time, but time nonetheless.
Right, a fraction of a microsecond, yes, but it still takes time, which means, scientifically speaking, the image you are currently experiencing in your brain is not the present reality. You are constantly, unavoidably seeing the past.
It creates a literal illusion of the present.
It's like watching a live television broadcast that has a built-in tape delay. You think it's live, but you're actually a few seconds behind the real action.
That's a great analogy, and the text points this out using some beautifully melancholic examples, actually. The author notes that you might be looking at a flower, but because of that microsecond delay in bioelectrical processing, that specific state of the flower is already gone.
Oh, wow.
Or on an even more profound level, when someone passes away, your brain still perfectly retains the image of their face and the sound of their voice. You hold on to a reality that the universe has already moved past.
Man, we are essentially trapped inside a neurological tape delay. We never actually touch the true present moment, do we? We are just watching a slightly delayed broadcast of the universe.
Huh.
The scale of that is just wild to think about.
It is mind-blowing.
But where does the author actually take this? Does he just view this tape delay as a quirky flaw of biology?
Far from it. The author looks at the seamlessness of this delay and sees proof of a designer.
Okay.
Think about the sheer computational power required to take raw photon energy, convert it to electricity, and render a flawless, high-definition, three-dimensional reality in your mind without you ever noticing the lag. The text argues that a program running this smoothly, converting energy to concept so flawlessly, requires a supreme wisdom.
Kind of like how scientists design a high-end camera, but infinitely more complex.
Exactly. It's too polished, too perfectly integrated with our consciousness to be a cosmic accident.
Well, if our brain is already performing this massive feat of editing just to let us experience a delayed reality, it makes you wonder what else our eyes are editing out. And according to the text, we are actually missing almost everything. And it's completely by design.
This is where we get into the physical limitations of the eye, specifically the 400 to 760 nanometer filter.
Right. Because human vision operates in a shockingly narrow band. We can only perceive visible light with wavelengths between 400 and 760 nanometers. If a wave of light falls outside that tiny window, it is entirely invisible to us.
Completely undetectable.
Yeah, and normally when we talk about biological limits, we frame them as evolutionary shortcomings, right? Like we wish we could see infrared like a snake or ultraviolet like a bee. But the author completely flips this perspective. The text argues that this limitation is not a flaw. It is deliberate, merciful design.
What's fascinating here is how the author asks you to imagine what the universe actually looks like if you strip away that 400 to 760 nanometer filter. If we could perceive the full spectrum of electromagnetic radiation, the blue sky wouldn't be blue anymore.
Here's where it gets really interesting. It would be a terrifying, chaotic soup. Your retinas would be bombarded constantly by infrared, ultraviolet, gamma rays, and X-rays. You'd see the radiation baking off the pavement.
It would be pure visual static.
But the text doesn't just stop at astrophysics. The author takes a massive leap into the metaphysical here, warning that without this visual filter, we might suddenly perceive spirits, immortals, devils, and even the literal thought waves radiating from other people's minds.
It is a striking escalation in the argument. The author blends the scientifically verifiable like gamma rays with the deeply supernatural, but it serves a very specific rhetorical purpose.
Right.
The author concludes that if the human nervous system were fully exposed to all of that raw, unfiltered cosmic data, we would go completely insane in less than 10 minutes.
10 minutes to total psychological collapse. And honestly, even without bringing goblins or immortals into it, just think about our modern digital environment.
Oh, that would be a nightmare.
Imagine walking into a coffee shop and suddenly being able to physically see the Wi-Fi signals bouncing off the walls, the microwave radiation from the kitchen, the Bluetooth connections between everyone's phones.
And everyone's literal thoughts flying around the room.
Exactly. We already feel incredible sensory overload just looking at our screens. If we had to visually process the invisible data streams surrounding us, we genuinely couldn't function. Is our biological ignorance the only thing keeping us sane?
According to this text, absolutely. Human limitation is framed as a protective feature. The author believes the greatest creator deliberately installed this 400 to 760 nanometer bottleneck so that we can exist as rational beings.
So ignorance really is bliss.
Yes. It filters out the overwhelming chaos of the raw universe so that we can actually relax, function, and appreciate the beauty of life. It's a limitation born of immense care, not evolutionary chance.
So we have this mercifully filtered bubble of reality that protects our minds. But once we are safely inside that visible light spectrum, the actual hardware of the eye has to be precise enough to keep our physical bodies alive. And the text gets incredibly specific about the physical dimensions required to pull this off.
Yes, the argument shifts from the supernatural implications back to rigorous structural biology. Take color vision, for instance. Inside the retina, we have cone cells containing 3 distinct photopigments.
Okay.
And these aren't just random receptors. They are mathematically tuned to absorb very specific wavelength. Blue light at 445 nanometers, green light at 535 nanometers, and red light at 570 nanometers.
Which operates almost exactly like the RGB pixels on your television screen, right?
Yeah.
By perfectly mixing just those three specific inputs, your brain renders the millions of complex colors that make up a forest or an ocean, keeping us from being colorblind.
Exactly. It's a highly efficient system.
Yeah.
But then the author pivots from the microscopic receptors to the macro physical size of the eyeball itself. We are looking at an organ that is roughly 24 millimeters deep, 23 millimeters high, and 23.5 millimeters wide.
Super tiny.
Very tiny. And the aperture letting the light in the pupil is only 2.5 to 4 millimeters across.
It is a tiny, fragile little sphere. But the author introduces this concept of the bamboo tube to highlight a profound paradox. Despite having a pupil only a few millimeters wide, our field of vision allows us to scan the horizon and take in landscapes stretching for dozens of kilometers.
Right, because if our vision were strictly limited to the physical dimensions of the eye itself, the author notes it would be like constantly looking through a narrow bamboo tube.
You'd have zero peripheral awareness.
None. You wouldn't spot the snake coiled by your foot, and you wouldn't see the wolf charging you from the side.
And to avoid that, we don't just have one eye, we have two, which brings in the critical math of stereoscopic vision.
Binocular disparity. Because our eyes are set slightly apart, each retina receives a slightly different two-dimensional image. The brain then instantly performs complex trigonometric calculations based on the parallax between those two images to perceive depth and distance accurately.
And the examples the author uses to illustrate the absolute necessity of this 3D depth perception are wild. The text points out that without stereoscopic vision, something as simple as threading a needle becomes nearly impossible.
Which is a very relatable, everyday struggle.
Right, but then the very next example the author uses is trying to accurately pour strong sulfuric acid into a small test tube in a laboratory with one eye closed.
A very dramatic shift.
Which is an incredibly stressful jump in stakes. I mean, we go from harmless tailoring to potentially melting your own hand off. I just love the sudden jump to high-stakes chemistry there.
It is a dramatic leap, but it perfectly anchors the underlying point. The author is intentionally weaving together vastly different requirements.
How so?
Well, the eye must be sensitive enough to appreciate the exact nanometer wavelengths of a delicate flower, right?
Right.
But it also has to be robust and mathematically precise enough to calculate the trajectory of a charging wolf or measure a dangerous chemical pore.
Wow.
The text argues that a single random mutation in a single-celled organism simply could not result in a multifaceted tool that perfectly balances aesthetic appreciation with such brutal survival mechanics.
But a biological sensor that delicate and that critical to keeping you alive, it can't just sit exposed to the elements. It needs armor. And the text describes the eye's physical defense systems using some of the most intense martial language I have ever encountered at a biological breakdown.
The author views the surrounding facial anatomy as the literal bodyguards of the eye.
Exactly. First, you have the autonomous blinking reflex. Every 2 to 8 seconds, we blink to distribute tears, moisten the cornea, and prevent dryness. But the author goes further, describing the eyelids as loyal soldiers guarding the frontier line.
Loyal soldiers.
Yeah. The instant a sudden flash of light or a fast-moving object threatens the optic nerve, these loyal soldiers instinctively slam shut.
The military metaphors continue with the eyelashes, which are described as bamboo curtains or two platoons of embattled sentinels standing guard to block the unannounced airborne invasions of dust and microorganisms.
It's basically a fortress.
It really is. Even the eyebrows serve a critical defensive purpose. The text frames them as an umbrella perched strategically on the supraorbital ridge to divert stinging, salty sweat away from the delicate tissue below.
But those physical barricades are just the first line of defense. Where it gets truly fascinating is the literal chemical warfare happening invisibly on the surface of your eyeball.
Right, because things do get through.
Exactly. When foreign bacteria do manage to breach the sentinels, your tear ducts flush them out. But tears aren't just water. The text specifically highlights that they contain compounds like lysozyme and immunoglobulin. The author notes that these chemicals actively hunt and kill bacteria by decomposing and this is a very specific term used in the text, the sucrose mortiorelate in their cell walls.
That is a highly specific, almost niche microbiological claim. Essentially, the text is describing how lysozyme acts as an enzyme that explicitly targets and severs the structural sugar bonds that hold bacterial and fungal cell walls together.
So it dissolves their armor on contact.
Yes, it dissolves their armor on contact.
It's biological chemical warfare. And the author uses this molecular precision as a direct challenge to the theory of evolution. The argument here is that a multi-layered defense system, featuring reflex barricades, sweat-diverting ridges, and targeted enzymatic attacks, couldn't have slowly evolved piece by piece.
Right, because a partially evolved eye would be completely vulnerable.
Exactly. The eye couldn't have survived millions of years waiting for its chemical defenses to develop. The text insists this system has been perfectly integrated since the very first humans appeared. It's never evolved or regressed.
And that leads directly to the culmination of the author's entire thesis. Because even with the military-grade defenses, the precise biological math, and the protective cosmic filter, the author concludes this chapter by stepping away from survival entirely and diving into a massive brainstorm about aesthetics.
Right, so what does this all mean? The text argues that beyond keeping us alive, the eye serves a profound, objective aesthetic purpose. It provides us with what the author calls bright, speaking, amorous eyes.
Amorous eyes.
Yeah. And to prove that this specific facial arrangement is a deliberate design rather than an evolutionary accident, the author actually runs through hundreds of alternative anatomical schemes.
It is quite the thought experiment.
It really is. The author considers what it would look like if our eyes were placed on the top of our head, the back of our head, on the palms of our hands, or beneath our mouths.
He even considers the aesthetics of swapping human eyes for frog eyes.
He does. And the absolute peak of this brainstorm is when the author seriously evaluates the biological prospect of placing human eyes on the buttocks.
It's an undeniably absurd image, but the author uses it to make a point about universal design.
And mechanically, you can easily see why those alternatives fail. I mean, if you have eyes on the palms of your hands, you can't grasp a tool or make a fist without blinding yourself.
That would be a major design flaw.
If you have eyes on the back of your head, you lose the predatory advantage of forward-facing binocular vision. And if you put your eyes on your buttocks, simply sitting down renders you entirely blind and vulnerable.
So biomechanically, the front of the face is the optimal high ground.
Right. But the author goes beyond biomechanics. He argues that any other placement isn't just functionally bad, it is objectively ugly. I mean, isn't beauty just subjective based on what we're used to? If we were designed with eyes on our hands, wouldn't we consider that the standard of beauty?
If we connect this to the bigger picture, that distinction is crucial to understanding the author's worldview. Often we assume that beauty is entirely subjective. We think that if humans had evolved with eyes on our hands, then hand eyes would simply be our cultural standard of beauty, but the author explicitly rejects that subjectivity.
To this author, beauty is not a cultural construct,
Yeah.
and it's not a byproduct of evolutionary familiarity.
No, to the author, beauty is an objective mathematical truth embedded in the universe. The text explicitly states, beauty is the masterpiece of the greatest creator, and the existence of beauty is the best evidence of the existence of the greatest creator.
So the fact that we find human eyes beautiful isn't just a happy neurological accident. The precise placement, the perfect symmetry, the emotional depths we read in them, this isn't just survival of the fittest. To the author, the aesthetics of the human face are the literal visible signature of a designer.
Exactly. The core argument is that you can witness profound, deliberate wisdom, not just in the microscopic enzymatic breakdown of bacteria or the exact trigonometry of depth perception, but in the sheer, undeniable aesthetic perfection of the final product.
Man, it is a massive intellectual framework to process. We've traveled from the bioelectrical tape delay that traps human consciousness in the past, through the merciful 400 to 760 nanometer filter that shields us from cosmic radiation and thought waves.
We've covered a lot of ground.
We really have. We've examined the complex trigonometric math that allows us to gauge the distance of a threat, the chemical warfare neutralizing bacteria on our corneas, all the way to the argument that beauty itself is an objective mathematical proof of a creator. To summarize the source text impartially for you, every single microscopic and macroscopic element of human vision is presented not as a triumph of gradual random mutation, but as the undeniable orchestrated masterpiece of an intelligent designer.
And regardless of whether you accept the author's biological premises or theological conclusions, immersing yourself in this argument forces you to reevaluate your own perception. It takes the mundane, everyday act of simply opening your eyes and elevates it into a highly complex, mathematically precarious event.
It truly makes you appreciate the machinery inside your own head. But before we wrap up this deep dive, we want to leave you with one final, provocative thought to mull over, building directly on the author's concept of the visual filter.
The author makes a highly compelling case that our inability to see the full spectrum of reality, the gamma rays, the X-rays, the invisible energy fields, is a necessary protective design that keeps the human mind from shattering.
But look at the trajectory of human technology right now. We are actively engineering tools designed to bypass that exact biological bottleneck.
We are. We have advanced thermal optics that visualize the infrared spectrum.
We have electromagnetic sensors mapping invisible fields. And even more profound, we are currently developing neural interfaces, brain-computer links, that are beginning to decode the electrical thought waves of the human brain into readable, transmittable data. We are artificially forcing our perception far beyond the 400 to 760 nanometer window.
Which raises a very unsettling question. If that biological limitation was truly a necessary design feature to protect our sanity, are we recklessly dismantling our own safety protocols?
Exactly. As we continue to unlock the technological ability to perceive the raw, unfiltered universe, if we eventually find ourselves swimming in a constant, visible stream of cosmic radiation and decoded neural data, can the human mind actually adapt to process it? Or will we discover, far too late, that the author was right all along, and the unfiltered truth of the universe really will drive us insane in less than 10 minutes?
It is a thrilling and a deeply terrifying frontier to consider as we push the limits of what we are built to see.
It really is. So the next time you find yourself marveling at the perfectly engineered specifications of a new camera lens, maybe take a moment to appreciate the bizarre, highly defended, and beautifully limited biological lenses that are rendering the world for you right now. Thank you so much for joining us on this deep dive into the source material. We'll see you next time.